So for this, check your understanding. How I would start is actually sketch on the unit circle the negative 510 degrees to see where you land. Remember, the negative means to go clockwise or backwards. And we are going to start right here in our sketching. Other thing I might do though is take the 510, subtract out a complete circle. To better understand, it would land me at 150 degrees. Again, this is going to be backwards though. So for the rotation, I'm going to go backwards a full 360 and then go backwards again 150 degrees. So be careful. A full half circle is going to be 180. It'll land me about right here. So it is landing me actually at the 210 positive degrees is where negative 510 degrees actually lands me. So I am going to be in quadrant 3. Now to answer the second part, find how many revolutions it is. We can actually tell, again, the number of revolutions, by the way, was 1 complete revolution plus not quite half of a revolution. So my answer for revolutions is going to be something like a negative 1 point something less than 5. I think the easiest way to do the conversion for this is let's just set up the proportion. So I'm going to do a full 360 degrees is 1 rotation. It's the same as 1 revolution. I don't know revolutions, but I know it is 510 degrees, again, negative on that one. And they do want decimals, so I can just literally type this in my calculator. And we're going to end up getting that the revolutions is going to be backwards again. 1 point to the second decimal place would be 4.2, which means you're going to actually rotate backwards a complete circle, which we already did, and then about 42% of a circle, which will land us here. Now, let's go on to part C, find the exact radians. To do exact radians, again, I'm just going to do a proportion for that one. So we're going to do, I'm just going to use the degrees. So full 360 degrees is the same as an exact 2 pieces of pi. That's equivalent. I don't know the radians, but this is a negative 510. Now, as you've heard me say before, personally, I like to simplify these larger fractions up front as much as I can. When I do that, I can tell nicely that the zeros do cancel out, so that's nice. So I'm left with negative 51 over 36. You might be tempted to think it doesn't simplify any further, but actually you can pull out a multiple of 3 from both of these if you want to. I'm going to go ahead and do that. 17 times 3 is 51, so this is going to become a negative 17. 3 coming out of the 36 is going to be our 12 on that. And then we have x over 2 pi. Last thing I want to do here is just solve for x. So to solve for x, let's go ahead and multiply both sides by 2 pi. And I'll do that over here also. And then just simplify accordingly. For this simplification, I'm actually going to come in here and just have this simplify out this 2 and then change this 12 here to 6. I'm just going to simplify my fractions. That then is going to give us a negative 17/6 of a pi is the same rotation movement. Keeping in mind, if I wanted to actually sketch this, again, sometimes it's hard to sketch the improper. If we wanted to sketch this rotation, it is helpful, in my opinion, to change this to a mixed number, even though we don't write the answer as that. 6 goes evenly into 12 2 times, or sorry, 6 goes evenly into 17 2 times with 12 and then a remainder of 5. So this is the same as saying let's go ahead and rotate backwards 2 pieces of pi and then 5/6 of a pi. Again, 2 pieces of pi is 1 complete circle. 5/6 of half of a circle basically would again land us in the same spot. Now the fourth part of here wants to find the approximate radians. If you have found the exact radians, the approximate radians is a piece of cake. All you need to do for that one is I'm going to actually move this up here. Go on in and just change pi to its approximate number. So do negative 17. Type the pi button on the calculator so we don't have as much of a rounding issue, but be something like this and then over 6. So you're going to get your approximate radians. Is going to come back here again as a backwards movement of negative. It's going to say 8.9 radians. Now, what 8.9 radians means, be careful. It means how many of the radii are going to be laid out on the circle. So it really is the same label. This is negative 8.9 radians. This is also radians and pieces of pi, but you move it in a different fashion. We are going to end up landing at the same spot. If we were to take this radii length and you lay it out, you're going to end up laying it out a complete 8 times with another 0.9, and you will land here. A little trickier to sketch by hand. The last part is give the approximate sine, cosine, and tangent value. To do this, what you want to do is actually look at your unit circle and see what we came up with. Remember to find the values for this ordered pair right here. All we need to do is I'm going to use our degree movement of negative 510. That ordered pair is actually going to happen at the cosine of negative 510 and the sine of negative 510. So you can either look at your approximate unit circle that we created earlier, or go to your calculator, make sure you're in degree mode and type these in and see what you get. You're going to notice that it's going to be a negative cosine value of negative 0.866 and then a negative sine value of negative 0.5. So the cosine value, the answer here, cosine is going to be our negative 0.866. Our sine is going to be negative 0.5. Now, we want to wrap this up then with the last part is to compute the tangent. Remember from this, we learned that tangent is the same as saying sine over cosine. So all we need to do is take our sine value, which is the negative 0.5, divide it by the cosine, which is the negative 0.866, and when you simplify that, the negatives cancel, we get a positive answer, so it's going to be a 0.577, which means the slope of this angle movement that we see is a positive slope, which it goes uphill, and it's a slope of 0.577. And that is how you do this warm-up.